My name is Koji Yasui, and thank you very much for giving me this opportunity to talk to you about digital twins and quantum computing to establish a digital society we are calling it the Society 5.0 in Japan. I'm working for Mitsubishi Electric Corporation and supplying solutions for industrial people. I'm also working to connect customer demands and quantum computing technology supported by Japanese government program SIP. So today let me talk to you having two caps according to the contents. Let me start with this slide to explain the position of quantum computing among industrial customers. This slide shows the change of customers' interest for discussion with me. About 8 years ago, whether we handle digital data mainly in cloud or edge was a big issue. 5 years ago, wireless technology such as 6G was the most interesting item from customers. Recently, we have been discussing data-driven or model-driven for total optimization of the system. And today, quantum computing is the most demanded discussion item, so I consider that a big chance is arriving for quantum computing society. In this talk, let me explain how we have been responding to customers' most important demands, including quantum computing, and how we have been preparing collaborating centers and institutes to supply quantum computing solutions, not only for Japanese customers, but also for global industrial customers. The first section is to explain how digital twins are required for quantum computing applications. This slide is showing the overview of the SIP program supported by the Japanese government. One of the objectives of this program is to eliminate bottlenecks related to building digital twins and also to eliminate bottlenecks related to the construction of connecting devices. Here, connecting devices are required to connect digital twins to the real world. Another objective of this program is to provide services related to quantum technology such as quantum computing and quantum communications. As you are familiar with the fact, the application of today's quantum computing is limited and cannot respond to the urgent demands from industrial customers. In the course of SIP activities, we have found out that if we prepare digital twins and connect them to quantum computing experts, we can provide valuable results for our customers so that they can use quantum computing for their today's applications. Let me explain the application target, picking up the application for production lines of manufacturing sites as an example. To construct a digital manufacturing system, people are building digital twins in the cyberspaces in the computers for all production facilities on the floor. In other words, for everything in the real space. To complete this system and to gain profits by using this system, in other words, to earn money, we need modeling of the production facilities, feedback control, and total optimization by using digital twins. Quantum computing can be effective for building models, but it is a bit long way. On the other hand, the usage of quantum computing for total optimization is already today's application. And we have recognized that it can be also applied to important applications demanded from industrial customers, as shown in the next slide. Yes, the same system developed for production lines can be applied to mobility fields and energy fields, but with reduced price requests from such fields compared with production lines. Because each component, such as cars for mobility fields and switching devices for energy fields, are less expensive compared with machines for the production lines. By using this slide, let me explain how the quantum computing is demanded for mobility and energy applications. People and cars, automobiles, for instance, are going to communicate by using connecting devices based on 6G technology. To optimize such a system, quantum computing is somehow required. By expanding the application, and if traffic objects such as traffic signals are included, to do total optimization, the role of quantum computing increases. And finally, to do total optimization, including power grids for energy field, quantum computing must be included in the information system to handle so many devices included in the system. Quantum computing is a must item for today's and future applications as explained so far, but it is still difficult to understand for industrial people. This slide shows the contents and the opinion that I myself have heard from our customers. As you can see on the top left, to my surprise, many of our customers have already tried quantum computing with little success. And as you can see on the bottom left, some of them doubt that this should be the story for academic people and for so-called POC business people to withdraw money from the government. On the other hand, as you can see on the top right, some customers are already requesting quantum computing for their production lines. And it is also true that some of such demands can be solved by using advanced AI technology, as shown in the bottom right. After discussing with them, I have found out major two reasons exist for the difficulty to understand quantum computing for industrial people. The first reason is that there are several alternative technologies such as AI. So customers are wondering how we could choose the best one or how we could combine several methods to obtain best solution for their demands. In other words, consultation service to propose the best solution, including quantum computing, is not sufficiently provided so far by either academic people nor commercial services. The second reason is also related to the first reason, and it is mismatching between customer demands and information we could obtain from Quantum Computing Society. Technical meetings and articles are mainly discussing programming tools and the quantum computers themselves, as shown here. But industry people need modeling of the target problem to build digital twins. If they obtain well-structured digital twins, then they can ask quantum computing experts to apply state-of-the-art quantum computing for the most important target to obtain profits for their business. Therefore, we decided to construct an ecosystem supported by Japanese government to help industrial people who are struggling to build their own digital twins, and also to supply quantum experts who can help those who have already prepared digital twins to go to next stage to use quantum computing for their real business applications. We are trying to construct the ecosystem that can handle from TRL1 to TRL9 level, responding to customers' individual demands to escape from so-called bridging program between the academia people and the business people. We have begun building core centers that can provide customers with technology to eliminate bottlenecks for them. But soon we have understood that such core centers can concrete relations only with new business people, such as R&D unit of companies, POC business people, and academic people. In other words, such structure is not enough to communicate with real business people. So we decided to construct an ecosystem that is shown in this slide to receive big business opportunities from business units of big companies and medium and small companies that are actually working in the business field. Of course, each center can collaborate to each other, and each center can work as a one-stop solution window institute for customers. This slide shows an example of a Kyushu University Center to explain how they're integrating technologies collaborate with other centers. Kyushu University can supply technical solutions for customers, and if customers request commercial solution, they are going to supply them through affiliated centers. Before concluding my talk, let me introduce several members of core centers of this system. The first is the core center of Kyushu University and the University of Tokyo. Collaborated with semiconductor big companies such as Tokyo Electron, Screen, and Sony, and so on. Kyushu University is preparing institutes that can supply AI and quantum technology services mainly for companies in Kyushu area, including semiconductor-related companies. And they have already discovered that today's quantum computing offers enough business advantages for companies to apply quantum computing to the production lines and businesses. And they are also promising companies that they will enhance the capability of quantum computing in the near future. This is a contact information for Kyushu University, so you can contact me or direct Professor Shiratani by using his email. Another example is a collaborative institute of MURC, Mitsubishi UFJ Research and Consulting Company. They are helping companies by showing business models to earn profit using quantum computing by analyzing the business situation and required solution for customers on the market. Let me introduce several slides about MURC that they are preparing for each core center. This slide explains the structure of ecosystem to supply solution for customers. And next slide shows how to respond to TRL1 to TRL9 level, again responding to demand from customers. And this final slide of MLC is an example to explain how the application of quantum computing is effective for semiconductor companies. Call center people can use this kind of slide to discuss with their industrial customers for real business applications. This is contact information for MURC. Again, you can contact me or directly Mr. Tanaka of MURC by using his email address. In summary, speaking about why we need digital twins and quantum computing, we need digital twin to apply quantum computing for real business to establish new digital society called Society 5.0 in Japan and to make profits from the viewpoint of companies. Next, related to number 2, understanding quantum computing. Yes, we can apply quantum computing today, even for industrial application, if we can prepare digital twins. Finally, number 3, ecosystem to supply quantum experts and digital twins. You can contact our ecosystem today, and you can try and utilize for your business today. Thank you very much for your attention. Your comments and requests for PDF files are very welcome by mails or by through LinkedIn. You can find further information on myself in LinkedIn and further information about this talk in ebooks by Kindle Amazon. If you and your colleagues prefer scientific articles for each course center and related companies, you can reach an article described by Nature magazine on the web. Finally, I feel very sorry that I cannot meet you on the conference room physically today. And you can ask me questions by mails, and you keep in touch with me and with our ecosystem would be very appreciated. Thank you very much.